We now move on to determinants of matrices. The determinant is a number, a scalar, that is associated to every square matrix M. So one way to think about it is it's really a function. Determinant is a function from the set of n by n matrices to the field. So if they're real, if they're matrices with entries in R, then it's a function to the real numbers. And so the determinant of a matrix is defined differently. Well, so the sort of overall definition is very complicated and is not touched on in this course. But the if we just look first at the 1-by-1 case and the 2-by-2 case, and then we'll move on to the 3-by-3 case. So the determinant of, so first we should, so this is a set of square matrices, not defined for other kinds of matrices. So the determinant of a 1-by-1 matrix is just the number that's in the matrix. So if we have the determinant of any 1-by-1 matrix with one entry x, it's just x. If we have the determinant of a 2-by-2 matrix, if M equals A, B, C, D, then the determinant of M, written det M, or sometimes M like this with vertical bars, or sometimes the matrix is written like this with vertical bars. So these are all three pieces of notation which all mean determinant, and it's defined to be AD minus BC. So this is the formula here for the determinant of a 2-by-2 matrix. So it's just this number, AD minus BC. This number is the determinant of a 2-by-2 matrix with entries A, B, C, D. Example. The determinant of the matrix 3 minus 1, 0, 3 is 3 times 3, that's AD, minus 1 times 0, which is 9. So it's just a number that's associated to the matrix. It does have a geometric meaning, which I don't want to touch on too much now because that's the subject of chapter 7. But one way to think about it is if you have a parallelogram, if we take a parallelogram with entries with vertices 0, 0, A, B, C, D, and if we have the last one up here, which is A plus C, B plus D, then the area of this parallelogram, I think you could probably show, if we shade it, this area is equal to AD minus BC, or technically, I guess, the modulus of this. So yeah, the modulus of the determinant gives us the area of this parallelogram in the 2-by-2 case. But we don't need to worry about this now. This is for later. A definition we need to know is that any square matrix M is called singular if the determinant of M is 0, or if and only if the determinant of M is 0. Otherwise, so if determinant of M is non-zero, M is called non-singular. Okay, so an example of a sort of question you could be asked about that is given that the matrix A, which is 4, P plus 2, minus 1, 3 minus P, is singular, find the value of P. So how could we do this? Well, the determinant of A is AD, that's 4 times 3 minus P, minus P plus 2 times minus 1. And that has to be 0 because A is singular. So this is 12 minus 4p plus p plus 2. So now we've just got a linear equation. So we've got 3p equals 14. So therefore p is 14/3. So that's the only possible value of p that makes a singular. What we now want to do is to move on to 3 by 3 matrices. So to find the determinant of a 3 by 3 matrix, we may expand, we'll say what this means in a second, along any row or column. So we have a 3 by 3 matrix, A, B, C, D, E, F, G, H, J. The only reason I don't use I is because I always think of I as being the square root of -1. So I don't like to use I, but you could use I. If we consider, so if we expand along the first row here, we have to, there's a special rule for how we determine the sign of each term, which is using this diagram here. So we're using the top row, so we're also going to use the top row of this diagram. So this just tells us, this plus minus plus thing tells us the first term we're going to use positive A. And then what do we do with that? We multiply it by what we get if we cross out the row and column containing A. So we multiply A by the determinant E, F, H, J, and then we add to that minus B. The minus comes from here, and then we do the same thing with B. We cross out the row and column containing B, and we multiply by the determinant of what's left. So what's left is D, G, F, J. And then we again use the plus minus plus diagram. We add C, and then we multiply C by the same thing. We cross out the row and column involving C. The stuff left is D, E, G, H. So we multiply by that determinant. So if you want, this gives you a formula, something like A, EJ minus HF, minus B, DJ minus FG, plus C, DH minus EG. That's not a very nice formula, so it's not worth, definitely do not memorize something like this. Do not learn. The thing to learn, if you want something to learn, would be the plus minus plus diagram, this, and the kind of procedure here. So to work out each entry, you cross out the so first you use the plus minus plus diagram, you multiply by the entry in the matrix, and then you multiply by the determinant of the submatrix left if you cross out the row and column containing that entry. So, so perhaps we'll just write down some steps for 3 by 3 determinants, how to work it out. So step 1 would be choose a row or column to expand along. So remember I chose the first row. You can choose any row or column, but you have to always use this plus minus plus diagram to make sure you have each thing having the right sign. So step 2, use this thing. To tell you the sign of each term. 3, that's when you write out, well, So in our case, it's quite hard to explain in words, but in our case, we took the first row. So for the very first term, we had plus 1 times A times the submatrix, times the determinant of the submatrix left when we cross out the row and column containing A. So multiply each term in the chosen row or column by the sign in the plus minus plus matrix in the corresponding place in this. So you multiply each term in the chosen row or column by the sign in the corresponding place in this, and multiply by the determinant of the 2x2 submatrix formed by crossing out the row and column containing the entry. So that's quite a mouthful. That's why we didn't start with the explanation in words, but that is the procedure. And this determinant, the determinant of the 2x2 submatrix formed by crossing out the row and column containing the entry, these are called minors, these determinants of the 2x2 submatrices, which is not really a particularly important word we need to know, but just for completeness, each of these 2x2 determinants is called a minor of this 3x3 matrix. Okay, so when I say cross out, when you're doing it on paper, I wouldn't advise crossing out. Just cover up with your fingers the row and column you need to get rid of. So obviously, we can't. Let's see some more examples. So if we want to work out the determinant of 502 minus 181,673, well. So first of all, pick a row or column. It's always a good idea to pick a row or column containing 0 if you can. So just to see a different way, I think this example's in the book, but we'll do a different way to the book. We'll pick the middle column. The book picks the top row. But just to see a different way of doing it. So what are we going to do first? Let's read the steps. We've chosen a row or column. We could just add to this. Helpful to choose the row or column with the most zeros. Just because then it'll be quicker. Because if some of these 3 terms we get here are 0, then it's quicker. Now use the plus minus plus. We're using the middle column this time. So the first thing's a minus. Minus 0. And then what do? We cover up. So let's just cover up the row and column containing 0. And then what's left? Minus 1, 1, 6, 3. So that would be the determinant. But actually it doesn't matter for us because it's a 0. So this term is already 0. It's just 0. And then we add, because the next thing's a plus, so now we're going to add 8 times the row and the determinant, the minor that's left, made up of the other 4 terms, 5, 2, 6, 3. And then the last thing is a minus, so minus 7 times 5, 2, minus 1, 1 determinant. Okay, so this is 8 times 5 times 3 minus 2 times 6 minus 7, 5 times 1 minus 1 times 2. So this is 8 lots of 15 minus 12, that's 3. And then this is 7 lots of 7. So we have 20, We got that right. 24 minus 49, yeah. So, so we can see if we subtract 24 minus 49 is minus 25, which is the determinant. And we'll just do another example. Let's find the determinant of 1, 2, 4, 3, 2, 1, minus 1, 4, 0. So again, if you ever do have a row or column that has a 0, it's easiest to pick that row or column. So let's use the third row this time. And so we've chosen our row or column. Now we use the plus minus plus thing. So for the bottom row, it's plus minus plus. So that's nice and easy. So plus minus 1 times the determinant made up of by covering up. So if we cover up these two, we get the determinant of 2, 4, 2, 1. And then minus, because it's a minus here, 4, that's the entry, times the determinant of 1, 4, 3, 1. And then plus 0 times something, well, we can ignore that because it's 0. And then we get minus 2 times 1 minus 4 times 2, and minus 4 times 1 minus 12. So we've got minus, well, that's 2 minus 8, which is minus 6, so we get plus 6. And then minus 4 times minus 11 is 44, so the answer is 50. So that's the determinant. And your calculator can work these out. There's a function on your calculator to work out the determinant of a matrix. If you're asked to work out the determinant of a matrix like this in the exam, you would just use your calculator. You do not need to do this procedure unless the entries in the matrix are algebraic. You would just use your calculator. But obviously, if we have an unknown in the matrix, if we have some unknown like x or k, then you can't use your calculator. So if we had an example like this, if we have the matrix A, which is 3, k, 0, minus 2, 1, 2, 5, 0, k plus 3, and we're told k is a real number, and the question is, given A is singular, find the possible values of k. Okay, so what does it mean to be singular? Well, recall from earlier, it means the determinant is 0. So this is telling us the determinant of this matrix is 0. So now we just need to find the determinant in terms of k. So let's choose the top row because that involves a 0. So we'll get 3 times the determinant of 1, 2, 0, k plus 3, minus, because the next entry in the plus minus plus thing is a minus, k times the determinant minus 2, 2, 5, k plus 3, and then we've got 0, so we can ignore that. And then we've got 3 times k plus 3, minus k times minus 2 lots of k plus 3, minus 10. And then we just need to solve this quadratic equation to find k. So this is 3k plus 9 plus, let's see, this is 2k squared plus 3k plus 6k, and then plus 10k. And then this is equivalent to 2k squared plus 19k plus 9. And then does this factorize? So notice if we have a 9 here and a 1 here, that works out. So therefore k is -1/2 or -9. And just one last one to think about that I won't tell you the answer to, but I'm sure you'll be able to figure it out, is what is the determinant of this 2x2 matrix here? So that's one for you to have a go at right now. And we'll stop there.